Hello. In this video, we're going to be building another AWS Lambda function to work in conjunction with the Amazon Connect Contact Center, and it's going to be developed in C#.NET Core. Unlike the last example that really didn't do anything, this one's actually going to provide some actual functionality in the form of a weather bot. So the way it'll work is you'll call in, you'll be prompted to enter in a zip code, and then we'll invoke a Lambda function that does a lookup from a public REST interface to get back to weather at that zip code location, format up a message, and then returns that to the contact flow, which will then play that weather information to the caller. So this picture shows the flow. On the left-hand side, we've got Amazon Connect contact flow executing. At some point, we've captured a zip code, and then we're going to make a Lambda request to an AWS Lambda function. That's going to be called actually WeatherLambda. That function will in turn make an HTTP GET request of the OpenWeatherAPI to get the current weather at that zip code location. That weather data, which comes back as JSON format, will come back to the Lambda function as a response from the GET request. And the Lambda function will then format up a message and return that to Amazon Connect, which will then play that weather information to the caller. To actually make this, the information will actually come from the OpenWeatherAPI, which is a free public REST interface that you can leverage. It's at openweathermap.org, and once you get here, you drill down on the API topic, and the interface we're actually going to be using is the first one listed here, get the current weather data information. Notice it says here available for free. There are some other pieces of information you can get for free, and they also have a paid service for historical and other details. If we look at the API doc for this, it has a number of ways that you can query for current weather, by city name, by city ID, so forth. The one we're going to be using is this one, the by zip code. And an example as shown here is that the URL that we send has to contain a query parameter that is the actual zip. So it's zip equal and the 5-digit zip code. So that's the API we're going to be using to build our Lambda function. We can test that GET request before we write any code just by invoking it from a web browser. So if we bring up a web browser and we paste in our URL, we can do a lookup, and sure enough, we get back what looks like weather data. It's a little bit hard to read, so another way to look at this is to bring up a utility like Postman, which allows us to make HTTP requests. And notice that we're passing the same 3 parameters that we passed over here, which is the units, the zip code, and then the app ID. So if you look here in Postman, you can see we've got the same 3 query parameters. We've got zip, we've got units, and we've got app ID. Zip is set to a New York zip code. Units is imperial because we want to see temperatures as Fahrenheit. And then we've got our app ID being passed from our Postman environment here. So if we do a send here, we do in fact get back weather data. And the fields we're actually looking at are the main field, which gives us an overall description of the weather, in this case rain. But we basically use the first entry we find. We use the main description of the 0th element of weather. Then for the temperature, we use main.temp, and we remove any of the fractional part of the temperature. And then the last thing we use is just the name of the city. So now let's create the Lambda function. As before, we're going to create a new Lambda function project. And we're going to call this function WeatherLambda. We'll base it on the empty function blueprint, which gives us a single function that we're ready to configure as we want. Here's the function, and this should be familiar from the last video. But before I create the Lambda function itself, I want to create a library that I'm going to use, and that's where I'm going to put all the logic that relates to accessing the OpenWeather API. So let's do that. So I'll create a new project. And this will be a .NET standard library, because that way we can use it from the Lambda function as well as a simple test program that we're going to write. So we're going to call this Weather Library. And let me get rid of this class, because what I'm going to want are, I'm actually going to have two classes here. I'm going to have something called an HTTP request, and that's where I'm going to put the simple logic to handle the actual get, the HTTP get that I'm going to make to the OpenWeather API. So let's go ahead and add that class. So we'll call this HTTP request. Yes. And I've actually got the code already developed. So let me just copy and paste that here. And what this code does is it's got a single method, initialize API client. What that does is it creates an HTTP client, which is a .NET object that allows us to do gets as well as puts and other stuff. And then we set up our request header so that we're going to accept JSON data. So that's really the extent of what we're doing here. This takes the base address of URL requests are going to make. So that's going to be an OpenWeather base address, as we'll see shortly. So that's one method. And then the other one is the method that we'll actually call to make the request. We will call this the processor. And again, I've got code written for that. Go here and paste that in. And so this has two methods. It's got the initialize weather processor, which takes the OpenWeatherAppID. So when you sign up for the OpenWeather API, they'll send you an app ID. It's a free sign up, by the way, so go ahead and do that. It takes about an hour for that app ID to be enabled, so you'll want to do that sooner rather than later. And as I say, it's free. You just give them an email and they'll send you that app ID. So the idea is that I want to configure my weather processor with the app ID, which I then store locally in this property. But the other thing I do when I'm initialized is I actually initialize that API client. And so that calls this method over here, this static method, to actually create our HTTP client. Then the other method that's in this code is a load weather method. And that takes, as you see, a zip code, string that is the actual zip code. And then it forms up the remainder of the URL per the specification of the OpenWeather API. And in this case, you can see basically what it's doing is it's taking, openweathermap.org/data/2.5/weather. So this is the actual verb that we're using to request the current weather. And then there's a couple of query parameters here. There's the units, which says we want the results back in imperial English. So the degrees will be in Fahrenheit specifically. And then, of course, the zip code, which is the key piece of information that we need to pass. And then the other key piece of information is this app ID. So you see app ID equals, and we're setting to the value of the OpenWeather app ID, which is this property here that was passed in when we initialized. Then we basically make our request, our get request. So this is our get request. We're making it asynchronously. And when we get, assuming that we get success, then we're going to read the data. And then we're going to extract certain information from that data. So here we see we get back a dynamic structure in my code. I'm saying I want the city, which is results name. I want the temperature, which is results main.temp. And then the temperature is, I actually then remove the decimal part, so I just get an integer temperature. And then the last thing is the actual conditions, which is going to be clear or drizzly or rainy or whatever. And then I form up this string with those three chunks of information. Basically the city, the conditions, and the temperature. And then that's what I return to the caller from this function. And this, of course, is asynchronous, so whoever is calling this is going to have to do a wait on this request. So I'm ready to build my library, but actually I'm not quite ready because I have to add a dependency here, or a NuGet package rather, for the API, the .NET API client. So that's going to be Web API client. So let me add add that package, and now I should be able to build my weather library. Let's see if we get a clean build here. Yeah, build succeeded. That's good. So now the next thing I want to do is create a simple Windows Forms application to test my library. The idea here is that I'm putting all my logic, if you will, into the library rather than the Lambda function itself. And so that way I can test a lot of this without actually uploading to Amazon and running Connect or running some of the test tools and so forth. Instead, I can just test it locally. And so that's always a good idea. So I'm going to now create a real simple Windows Form app. So let's add a new project. And this would be just a Windows Desktop Forms app based on .NET Framework. And I'll call this WeatherForm. Okay. Now, before I get going, let me add a reference to that same package. I will need it since I'm referenced. So I want to browse to API. All right, so this is our form. I'm just going to create a couple of label text box. Let's see what I'm building here very quickly. A button and a text box. All right, let's make this one multi-line. And this is going to be enter a zip code. And this text box is going to be called zip code, so we can reference it in code. And this button is going to be our lookup button. So we'll call that lookup. Weather. And let's change text to be lookup weather. And let's make this text box, let's call this results. And let's make it multi-line. It is multi-line, so let's go bigger. Whole dialog a title of WeatherForm. What we want to do is when this form loads, we want to initialize our weather processor. Let's go ahead and do that with this code. So we're calling our weather processor. Now we need to add a reference from our form to this library, to the weather library, in order to call that weather processor method. And then we also need to have a using for this guy, using WeatherLibrary. So now we're calling the initialized processor. The other thing is that I'm trying to pass a property here of OpenWeatherAppID. So I need to create a property for my app ID. So I'll just do that here in my form settings. So that's my OpenWeatherAppID, and I'll give it a value of save that, and now I should be good there. Okay, so that's resolved that issue. That's form 1 loaded. Now the other thing is that I want to actually perform my lookup, and so I need to put in a click handler for that event, and I'm going to drag and drop that code. So what I want to do, pretty simple, is I want to clear my results, and then I want to make my request to the weather processor to load data. And then I want to use that to actually update. And I've got to make this an asynchronous message because I'm using await in it. So I should be good to go now. Let's see. Let's do one other thing, which is so that I don't have to keep entering test zip code. Let's enter one right now. 10118, New York. 8. All right, so now we should be good to go. Let's build it and run it. I should set it as a startup project. And then run it. All right, so here's our form. We've in theory already initialized our weather processor. Let's go ahead and do a lookup, see if we get it back. All right, success. So our function worked. We successfully made a REST request to the OpenWeather API, and we got back a valid string here. We can step into this, for example. That's a nice thing about doing this in Visual Studio using a Forms app as a test harness is I can put a breakpoint, for example, right here, and then run this test again. I come in here, now I can single step into here. I can step through this method. I make my request. I check for success. I get my data back. Life is good. I'm getting my temperature. I can see other stuff in my results. Here's all the other information there, and so forth. So that's one of the real advantages of developing this test app independently of the Lambda function. All right, so we're good to go. We've got our library built. We've got our form test app built. So now we're ready to focus on our Lambda function. So let's jump back there. Okay, so now we're going to drag this code over and paste that in. So this is our Lambda function. It takes a dynamic, like the other example, the previous example I did, and it returns an object, just like the previous example. So we still log when the function handler starts executing here. Now what we're doing is we're checking to see if we've already initialized our API client. Because unlike the form example, there's not an obvious place to put that initialization code. So what we do is we check this member of our HTTP request, the static class that we built that's part of our weather library. We check to see if that's null. And if it is null, it means we haven't initialized yet. Or at least this instance that's being run by AWS is not initialized yet. So if it is null, then what we do is we get our OpenWeather API. We get that from the environment. So that's the understanding here is that we're going to be passed this as part of the environment from Amazon Connect contact flow. And then we're going to use that in our initialized weather processor request. We're passing that app ID in. So once we've initialized our weather processor, now we're ready to actually make our load weather request, which we do down here. So here we're extracting the zip code from our input data. We're making sure we got a zip code. If not, we log an error, and we return as a message, zip code parameter was not set. That's what the guy will actually hear if they didn't give us a valid zip code. So it's sort of a poor man's debugging information feedback here. Otherwise, we log zip code that we're going to use, and then we actually make the request here. We do the load weather. We then write out in our log what that message is that we got back, and then we return it here. So that's the idea here. for this Lambda function. Notice here we format it as a JSON response, and of course if we get any kind of exception, then we notify them of that. So the whole project now should build, and it should be we need to add we need to add the reference to our weather library, to the Lambda function. So dependencies, add reference, and we need weather. All right, build. We are good to go. Okay, so now we've got a valid Lambda function ready to be uploaded to AWS. So let's go ahead and do that. We'll publish it, and we're going to call this WeatherLambda. 128 still fine. And the main variable here we need to set is that weather, OpenWeather, OpenWeatherAppID, and we will plug in my unique ID. Obviously, if you're doing this on your own, you're going to plug in your ID. So then I add that. So let's see. Now the other thing, of course, we need a role. So we can just use we could use our Connect Lambda role from before, because that's actually okay. But I'll go ahead and create a unique one for this guy. And again, all we need is the ability to write to CloudWatch logs. Let's go ahead and upload. Again, the first upload here, because it's creating a new role, takes a little longer than normal. Okay, just for kicks, let's do a test of our Lambda function right now. Let's make sure that everything is good. So we'll post it. I'll paste in this test data, which is basically just passing that single zip code, and I'll do the invoke. And there we go. We got our message back. The weather in New York is rain with a temperature of 40 degrees. So it's all working. Now the last step is to update our Lambda call flow. Our Amazon Connect call flow to use that message. So what we need to do is we need to go to our management console and get the Amazon resource notation for that Lambda function. So we drill down on Lambdas, and the weather Lambda. Here's the ARN up in the right-hand corner here. We'll copy it to the clipboard, and then we will go back to our contact flow editor and edit. So what we need to do is we need to insert our ARN into this step instead of the one that's currently here. So there's our weather Lambda ARN, and we should now be able to test. Last thing, of course, is that we need to save and publish. Do that, and we are saved and published. Now it'll take it can take about a minute, I found, for updates to contact flows to actually register online. Kind of a pain in the neck, but because it undermines your confidence. You know, you'll test and you'll think, gosh, I just changed that code, it should be working, and of course it's not. And then you try again, and then it does work. So if you think something's not working as it should, then that's usually a sign that that your update hasn't quite been applied, that you tested just a little bit too early. So let's try calling now, and hopefully it's good to go.
Please enter a zip code to hear what the weather is there. Lambda function failed.
Okay, now I think I know why that happened. It's the usual problem of privileges, but let's verify that. If we go to CloudWatch and we look at our log from our test, we get access denied. So that's a usual problem. So what we're going to need to do is quickly format add permission request for this particular function. So the function name is WeatherLambda, and then we need the ARN of our call center. So for that, we go to Amazon Connect, drill down on our instance, and here is that ARN. All right, so we've replaced the ARN here at the end with the one we just copied, and this is our account number here. So I can actually get it out of this ARN. I could also get it from the management console. So that's our full ARN. Now we need to invoke this on the command line. Okay. So now it's adding that permission. Okay, we're ready to test again. Let's bring up our contact flow just to remind us what should happen.
Please enter a zip code to hear what the weather is there.
118.
The weather in New York is rain with a temperature of 40 degrees. Please enter a zip code to hear what the weather is there.
Okay, let me try another one.
The weather in Newport is clouds with a temperature of 41 degrees. Please enter a zip code to hear what the weather is there.
All right, one more time.
The weather in Fall River is clear with a temperature of 41 degrees. Please enter a zip code to hear.
So that shows it's working, and it's dynamic. It's giving us different information based on a different zip code entered. There's obviously other stuff you could do with this. We could use some of the other APIs that OpenWeather supports to do, like future forecasts. So I could call in and get a forecast for tomorrow. Maybe it could remember my, it could use a DynamoDB to remember that I had called in the past and ask me if I wanted to look up the same zip code again, so I don't have to re-enter it, things like that. So there's a lot of possibility here. And it's also opening up the idea to a Lambda function that's doing more than just acting as a placeholder. So that's it for now. Bye.